Let's start. Hi, everybody. We're going to be taking a quiz on Thursday, so that should be your major focus. I'd like you to make a note to yourself about the format of the test on Thursday and some little bookkeeping things that would be important to you right now. Here comes Evan. Good, thank you. We'll get them in here. All right, and then there were four people left. Okay, so all homework that was assigned for this afternoon is due tonight at 11. I'm going to be going over a lot of those problems. I see that more than half of you didn't finish all 10 questions yet. So I'm going to be going over a lot of those today. So if there's one that you struggled with or guessed at or gave up on, today's going to be your day to get some good help on that, okay? So take good notes today. And what else? Trying to stall for these last few people to come in. Oh well, they're late now. Okay. Any homeworks that are outstanding or unfinished or any of that kind of stuff, you can ask for an extension. Homework C is not due till tonight at 11, but if you didn't turn in the lab, turn in the lab, which is most of you are done with that. You have 4 homeworks to do for this section. So if there's one that's incomplete or you're not happy with the grade, please do that. Okay, on your paper, please write the word Skyward. Skyward. Please check your grade and grades in Skyward. If I miswrote it or you updated it somehow and I didn't catch that and it's a lower grade than you deserve, please send me an email and I'll fix that. I've been trying to get stuff into your Skyward so you and your parents and the counselors and everybody in the world can see how you're doing in AP Physics. Most of you are getting an A or a B, and that's the way it should be. So if you're not, then you got to catch up. So you have until Thursday afternoon at 1:20 to catch up on these old things, because then we're going to move on. And I don't want to be doing all that catch-up work after your test on Thursday, because we're going to go on to chapter 3, which is more exciting because it has projectile motions, which is darts and arrows and baseballs and footballs and stuff like that. So if you redo something, and you can have a higher grade right now, I'm not penalizing anybody for anything that's been redone or corrected or anything like that. Okay, but you have to ask for an extension or else it won't let you submit it. So please note that. You have to send me an email. I watch that a bunch of times every day, and I'll give you an extension, okay? Oh, what else is on our little list here? Let's give you a format for Thursday's test. So here you go. So I'm going to give you 80 minutes. It's going to be timed. 80 minutes, about 5 minutes max per question. So what that gives us around 16 questions could be on this thing, 16 problems like your homework sets. Now you've had 10 problems in your homework sets. Some of you have taken a long time to do those 10 problems. So today I'm going to try to speed you up by making you more confident so that you won't take a lot more than 5 minutes per question. So think about 16 questions, and about 5 minutes per question. And it'll be 80 minutes timed. And each person gets a different test. Each one's got your own unique set of values. So please don't go sharing your screen with your friend in Canada or something that's going to help you. Okay, so try to do your own work. You should feel confident enough after today's class that you won't even have to look over into your notes to see, oh, I remember that problem. You can just do it, okay? Here's another note for the test. You get 2 shots at each question. 2 chances. So if you miss it and you type in an answer and it says X, that means something's wrong with it. You get another chance at it. Now, it's important that you get the first part of a question right because probably the second and third parts depend on it. So you want to really nail that first part, get that green check, and then go to the next part if it's multiple steps. Only about probably less than half of the questions will have a multiple step like that. Okay. And if you have any questions, just put it over here on the side. Okay. Okay. I plan to go over the equations today. Some people say that that's the hardest part for them is to, what equation do I use? How do I start this thing? Well, I'm going to model for you how to do all the problems, which is to read the question, get the data, draw a picture, come up with a starting plan. So I'm going to be doing that with you all day today. So hang in there, and I hope this helps you. The other classes thought it was very valuable. So I hope that works for you too. Okay. All right. So let's start if you wish. And here comes Edith. Good. Let's get these people going before I get rolling. All right. So I'm still missing Ben, and that's it. Just missing Ben. Oh man. So anybody had a class with Ben Bertner today? Anybody had a class with him today? Ben Bertner? Wave your hand if you did. All right. You did? Oh, I had perfect attendance for today except for him. I'm gonna be on his case. Okay. All right. That's okay. So let's get started. I'm going to do some formulas with you first and definitions, and then we'll go from there and we'll go some real easy problems first, and then we'll make them a little harder and a little harder. Okay. So let me switch this over to Elmo. If you have questions, please go ahead and put that into the chat box. And let me switch this video over to Elmo. All right, so that you don't get to see me anymore. Bye for a while. All right, and this is going to be chapter 1 and 2, definitions, and equations. Now, all this is a review. I mean, you already know this stuff. So, and any of you that are here, let's see, especially Akia and Kwa, you guys are next to me on my screen. So if you can't see it, you two guys tell me, okay? All right, so there we go. Let's go in with definitions first. You ready? Definitions mean these things that they're a formula, but they're basically a thought idea. The idea of what was speed. We started there. Speed is how quickly are you covering distance. Distance, the rate at which you're covering that. So that's distance over time. So we reduce that to a V for speed or velocity if you know the direction, distance or displacement if you know the direction, and time down here. So it's the rate at which you're covering time. The standard units, of course, are meters per second. What can you have on your quiz on Thursday? What would I have nearby? I'd have that, probably this sheet that we're making right now, which is all the equations, or you could have your other equation sheet that's given out. It's on your, I think some of you may have printed it out already, but I'd have my calculator working. You're going to have, you can have all your old problems and things, just have that over on the side, but you should be able to attack this test without much other than the basic equations. All right, here we go. So speed is distance over time. We also had this thing called average speed. And they call that V bar, put a little bar on the top, not an arrow, but a bar. And that is, no matter what you were doing, if you know how far you went, even if you're accelerating, stopped, went to the bathroom, all that stuff, it's the total distance over total time tells you average speed. And that's very useful sometimes. If I am averaging 50 miles an hour on a trip and I go 10 hours, then I should be 500 miles away. Okay? So this is, now, the other thing for average speed is if you're constantly changing, you can just find the middle number. And that becomes useful too, the middle number. So if you're constantly changing, you can't do this if you go 1 hour at this and a half an hour for that. It's if you're constantly changing, the middle number becomes important to us. Okay. Next is the definition of acceleration. And acceleration says that you're going to change your velocity, speed or velocity, with respect to time. The units are going to be meters per second, okay? Which means that if I want to know the final speed for something, I just multiply the acceleration and how many seconds was I doing that. And if I had something to start with, that goes over there. Now, sometimes the acceleration is gravity. If only gravity is the only force, the force of gravity is the only force on it, the only accelerating factor on an object, then we call that minus 9.8 meters per second squared near the surface of the Earth. And we use a little g for that. That's a little g, okay? Now there's two equations that we have. Those are definitions. There's two equations that we have that are very useful. One has time in it and the other one doesn't. So the first one says, if you want to know where something is, 1/2 at squared plus starting speed times time. That's where something is if it's accelerating. Now note that the right side is because of the speed. Where are you because of your starting speed? Oh, that's the same thing that we have over here on the left. Distance equals speed times time. So because of your starting speed, where would you be? This part right here says because of your acceleration, what else is added on? What else is added on? Now, that A could be gravity, and that would be minus 9.8. All right? So that's one thing. Now, if you don't know, if you have a starting speed, there's a problem here, and some of you figured out how to do it. If you don't know, if you know the starting speed, but you don't know time, then you have to use the quadratic formula. And I saw that some of you already used that in the homework to solve for time directly. How many, wave your hand if you used the quadratic on this homework? All right, and you did it successfully, okay? How many of you really don't appreciate the quadratic and you'd rather do it without? Wave your hand. Anybody? No? Okay, that's me. If you're handy with the quadratic, it's fine. But there's another way to do it, and I'm going to show you both ways today. Okay. All right, and then the other formula is this one: V final squared equals V initial squared. These are V's, not funny looking horseshoes. Okay, just V's plus 2AD. I'm going to use D instead of X. Your book uses X. Okay, where is the equation sheet? There's an equation sheet that's listed for you in our course materials. I will put it also into Schoology for you. I'll put another copy of it into Schoology in case you can't get there or you've lost it or something like that. Okay, I'll do that. It's also on AP Central for AP Physics 1. There's an equation sheet there for you too. Okay, thanks for asking. Now this formula here has no time in it. Okay, so if you don't know the time, usually this one's used to find the final speed. If you know how far it's gone up or down, you know that might be gravity. This might be how fast you threw it up or down. This tells you at that place, this is the speed it's going to have. This is very useful. There's no time there. And then you could come back over here if you know that final speed and use this definition to get the time. And then you don't have to use the quadratic formula. Okay? But you can do it either way. You'll see both of them today. All right. So those are definitions and equations. I'm gonna box them in. 2 equations, 3 definitions. All right, we got speed over here on the left. acceleration, distance, and all right, we're ready to go? All right. So I've got 3 quick problems for you that I'll do. And we're going to start with, let me see, I've got some other things, some notes here. Let's do a ramp first. You ready? This is a review of Galileo's lab. I really appreciate that you've turned that in, and we got some pretty good results. And this is problem A. This is a ramp. Okay. And this ramp, we're going to just go ahead and tell you the acceleration was 1.5 meters per second squared down the ramp. Okay? It's headed down the ramp. It's picking up 1.5 meters per second every second. It starts at rest. That's a 0. Notice I'm putting in a sketch and I'm putting in the values for everything I know onto the sketch with a variable, okay? And that helps me pick out what formula to use. Now, 1, 2, 3. At t equals 3 seconds, it gets to the bottom. There's a little steel ball. And I'd like to know what is the speed at 3 seconds and what is the distance at 3 seconds, okay? And you should be able to do that in 1 minute. Go. This is like a piece of candy for you. I mean, you've practiced. This is our 4th week of physics. This is easy. If you like Hershey's chocolate little kisses, this is a little chocolate kiss for you. You've all had a nice lunch, I hope. Now, I'm not going to ask you to put your numbers into chat yet because this one's still pretty easy. This is pretty easy. So let's do that. Speed, since it started at rest, is just a times t. It's accelerating at 1.5. And for 3 seconds, notice that seconds goes away, and I end up with 4.5 meters per second downhill. Okay? All right, everybody set? Now, if you can't see my thing, you guys got to complain to me if I'm writing over on the edge or something, okay? Now, distance can be done 2 ways. I'm going to show you both ways. 1/2 at squared plus v initial t has no starting speed. So that'd be 1/2 times the acceleration of 1.5 times 3 seconds squared. So that's 0.75 of 9, and 0.75 of 9 is 6.75 meters. Now let's look at the other way to do that. The average times time. We did that with the ramp. We did that when we laid out a whole bunch of numbers for a ramp. What was the average speed here? Well, it goes 1.5 here, goes through 3. Oh, we know that it gets up to 4.5 meters per second. The average between 0 and 4.5 is 2.25 meters per second. And we're going to multiply that, 2.25 times 3 seconds. And if we do that, oh, that gives us the same number, 6.75 meters. Okay, so we get the same answer. Depends on which one you want to use. Okay. All right, enough of that one. All right, let's move on. Sample question B. Sample question B.
Can you review paper? Yeah.
Yep, I will. Sorry. There we go. Sample question B says that over the weekend since Thursday, I asked you to find your own reaction time. Okay. This is you and all your fingers over there. You're using your thumb and first finger, and this thing is going to fall. Okay. Now, surprise me. Tell me that you actually had somebody help you find your own reaction time. Wave your hand if you did that. You found your own reaction time. Only one person? Oh, okay. All right. 1 or 2. So you got, all right. Good for you. All right, because we're going to make this a problem. How many of you tried the bill thing with a friend and let them try to grab the bill? One person? Who's this over here? All right, Edith. Did they grab it or not?
1 out of 3 times they did.
Okay, so 2 out of 3 they didn't. Yeah, and probably that one time they saw you flinch and grabbed it because it's really, really hard. 1 out of 100 people can get it consistently. So thank you for trying that. You other people are being lazy. Come on. I give you all these great ways to win money and you don't take it. All right. All right, good. Let's do this. So let's use gravity as negative 9.8 meters per second squared. And let's say the drop distance turned out to be 11 centimeters. What was the reaction time that we could calculate, not using a computer, just using a ruler and a little bit of math, and physics, we can find out the reaction time. Oh yeah, equation sheet. Yeah, it's under Schoology, under resources. Good, thank you. It's in there. So let's calculate this. Now I'm going to ask you to put your answer over in the chat because I found out this morning that there's 2 ways to make a mistake on this. I want to see who's making it. Go. I want 2 digits of information. 2 digits of information. Type in the reaction time that you calculate over on the right. And I really appreciate you guys working hard today and being in AP Physics. I really appreciate you guys. I think AP Physics students and Calc students are probably the best kids to be teaching in school. I guess that's why I picked to teach physics. I'm looking for numbers over in the chat room. Come on. You can do it privately if you don't want to show everybody, or you can just kind of type it in and share it. Let's see, I'm waiting for a couple people to get it. Oh, there we go. Yep, 0.15 seconds. Thank you. 0.15 seconds. I'm going to put a box around the final answer there so it's easy to find. 0.15. How did we do that? D equals 1/2 AT squared. T equals root 2D over A, but now it's gravity is the A. So it's root 2. We have to have meters, 0.11 meters over negative 9.8 meters per second squared. Ooh, that's a problem. You can't have a square root of a negative number. This 11 centimeters was down, so that's a minus also. So it's the square root of 2 times minus 0.11 over negative 9.8, and you get 0.15. Okay? Everybody got it? Now, the big mistake people made this morning was forgot to turn it into meters. Everything has to be meters and seconds, not kilometers or centimeters or anything like that. Okay? I hope I'm not going too fast for you. All right. Let's go to number 3. C. Third practice problem. As if you were on the quiz right now. Okay? I've got a runner that's going to do the 100-meter dash. Some of you are probably on the Olympia track team and probably have done this. But this is a special runner. This runner only runs with an acceleration of, let's say, 2.00 meters per second every second. Every second, they're like a little wind-up toy. And you wind them up and let them go, and this one accelerates at 2 every second for the 100 meters till they cross the finish line. Okay? I'd like you to tell me, how fast do they finish? And how much time did it take? Now, real runners have great acceleration at the first second, right? At the very first second. And then after that, their acceleration goes down, even though they're going faster and faster and faster. Okay. So now when you have these two numbers, put them in over on the side. This is pretty simple. You're going to find out it's a pretty quick problem. How long did it take and how fast are they going at the end? Show me over in chat as soon as you got it. Now, if you're not quite getting these, yeah, I know Wi-Fi is shaky in different parts of our county. Yeah, the final speed's going to be 20. We know that. And how long did it take? And if you're not getting these, if you're patient, I will show you how to do it. So don't get flustered or anything. You're too young to have wrinkles. The answer to the previous question up here, let's see. With the reaction time, reaction time was 0.15 seconds. Okay, and 10 seconds. Good, you guys got it. Thank you. Let's do these. So let's do the time first. So D equals 1/2 AT squared. T equals root 2D over A. So root 2 times 100 over A, which was 2. Those two cancel. Square root of 100 is 10 seconds. 10 seconds. Now I can do this two ways. 1/2 AT squared, speed. A equals V minus V naught over T. V final equals AT. We have acceleration of 2 times of 10, that's 20 meters a second. Okay, 20 meters a second. And that makes sense because my average speed, let's see, distance equals average speed times time. Let's see if that makes sense. My average speed would have been 10, right? Half the time slower than 10, half the time faster than 10. The time is 10 seconds, and that ends up being a 100-meter dash. So that makes sense. We just checked our answer a little bit there. Okay, that's a runner. Can you do an example like number 1, web assigned? Yeah, can you remind me when I start doing all those? Can we use the V final squared for this? Yes. V final squared equals V initial squared plus 2AD. V equals root, didn't have any starting speed, 2 times A times D, which equals 20. So that's another way to do that problem, okay? V final squared. Evan, I'll like number 1 on the web assigned and finding displacement. Okay, yeah, can you remind me at the end? I'll do that one at the end, okay? All right, let's go to homework C now. Let's go to homework C. So this is going to be homework C, number 3. We're going to start easy and make them just a little harder as we go along, okay? And I'll give you a little time to get it going, and then I'll kind of chime in and show you what I would do. All right. Number 3 says that we've got I think this is a dolphin one, jumps up in the air and comes back down again out of the water. And it leaves with a speed of 13.9 meters per second. And this is the starting speed up, 13.9 meters per second. I hope you can see that. And they want to know how high off the water does it get? What's the height? So H equals this. And how long is it in the air? And we're going to use gravity as negative 9.80 meters per second squared. Notice that that's 3 digits of information. Anytime they tell you 9.80, and 113.9. Those are each 3 sig figs. We want an answer with 3 sig figs. So let's come up with the height, and let's come up with the time, okay? And the hint here is, what is the speed at the top? It's 0, right? The speed at the top is a 0. And if you get that, that's a big hint because it helps you get the calculations going. So how high does it go, and how long is it in the air? Okay, go. I'll give you a minute or two. How many sig figs? 3. We want 3. So we've got a 13.9 and we've got a 9.80. Those are each 3 sig figs. Okay? No matter what the calculator tells you. Somebody wave if you're a friend of Ben's. Who's a friend of Ben? Ben Bertner. Who's a friend of Ben's? Nobody in here? Come on. Somebody a friend of Ben. I want you to get him these notes. No, but can anybody, who can volunteer to do that? You can? Would you do that for me? So who's that? Edith, did you raise your hand?
Sure.
Oh, can you do that for me? Okay.
Mm-hmm.
Yeah. I don't know if you can scan this or whatever, but take a picture of it or something, but make sure he gets these pages for today. He's the only one that missed from physics today. Okay, here we go. So let's do this. Let me see you over on the side, and if you've got how high he jumps, I want to see meters. And then if you know how long it's been in the air, give me some seconds. Go. All right, Akia, you're right. That's good. And the time, this is total time now, not just up. I need total time. 2.84, good, that's it. All right, so we've got some right answers over there in chat. So let's see if we can show you how to get those things. Well, I'm going to do it a simple way. I'm going to say, how long does it take to get to the top? So it's going to be V final minus V initial over time. I'm after how much time did it take to the top? To top. Time to the top. I know all these numbers except for T. So it ends up going 0. It started at 13.9. And the acceleration is minus 9.8 meters per second squared. The time to the top, I divide that and I get 1.42 seconds. Now, because of symmetry, and we're coming back to where we started, the T total is going to be double that, 2.84 seconds. So I'm halfway done with the problem now. All right. Now, what's the other question? Oh, how high does it go? Well, I can do this 2 ways. Let's show you. Distance equals average speed times time. That's the easy one. Or D equals 1/2 AT squared plus V initial T. That's the harder one. It's not harder, it's just longer. Okay. So my average speed was 13.9. And it got up to 0, the middle number is the average number. Okay, notice how to do that. That's the average speed, and we know that the time going up is 1.42 seconds. So the height, D is the height, H is height, is going to be equal to 9.86 meters. And that's the answer. Okay. Now, I went rather quickly once I started it, but you should be able to almost go as fast as me once you feel comfortable. And, all right? The biggest complaint I have from first-year physics students is, which equation do I use? What do I do? Well, notice what I did on this problem. I laid out everything given, on a sketch and everything that's unknown so that I can pick out from those two formulas or three definitions what to do next. Okay? And if I'm given time, or if I know time, it makes everything's easier. Okay, let's go on. Let's do number 4. This is homework C, number 4. Now, if you had trouble with this on your homework, now I noticed that less than half of you had the homework completed this morning and got a 10 out of 10. I already wrote those numbers down in my book so I could see how many are done. Most of you have problems left to do, so I want you all to get 10s on this. I hope you know that. Okay, so here we go. We've got this thing that's a diving board. Oh, here we go. We've got a diving board, and this person jumps off the diving board at 3 meters per second equals VO. It goes up and comes back down and hits the water. And the water is H equals 1.80 meters from the water to the diving board. And they want to know a couple things. How high does it get? I'm going to call that up. How far up does it go from the diving board? How long is it in the air? How long is it in the air? And how fast does it hit the water? V final. Okay, so we have H up. What's the height that it reaches above? So we have 3 unknowns. We're going to use gravity as negative 9.80 meters per second squared. And the height of the water, this is given, and the starting speed is given. That's everything you need. Okay, go. If you get any of those 3 things, you can type them in on the right, and I'll give you a thumbs up or a thumbs down. Height is 0.0459. That's correct. Okay. Akia, you're fast. Good for you. Now, there's different ways to do these problems. It doesn't have to be done exactly the same way by everybody. You can go after the V final first. You can go after the height first, the time, all those guys. There's different ways to do this problem. So, okay, I'm waiting for final velocity and time in the air next. I like seeing the top of your head moving. That means you're actively calculating, you're not sleeping. Let me let somebody come up with total time and final speed. Now the velocity has to be negative. A couple people were missing it on the homework because they were making it positive. It's on the way down, so it has to be a negative. Time. I got a little different time. That's close. April, that's close to what I got, but not exactly. 922. I got 985 actually. But it depends, maybe it depends on where you round off, but I got 0.985. And then final speed, let's see if somebody can come up with that velocity. Final velocity. Okay, and I hope you're finding this useful. Final velocity we're waiting for over here, you guys. Now, if you feel overwhelmed by this problem, I'm going to go through it step by step, but you should be able to do this. Final speed, no. Oh, you guys are funny. 3 digits of information, please, Bahar. Three digits. 3 sig figs. Nope. Maybe it is according to your data, but mine, I had negative 6.65, but that's probably close enough to let it count it correctly. Okay, I'm going to do this with people, and whether you had trouble or not. So let's go and find, let's do these a different way. Let me find the time to the top. Time to the top. All right. And if I find the time to the top, I can find the height of the top pretty easily. So I'm going to use A equals V minus V naught over T, the time to the top. We stop at the top. Okay, again, we're using that idea. We're stopping at the top minus, we launched at 3 meters per second, and the gravity's taken away 9, adding a negative 9.8 every second to the velocity. So that time to the top is just a 0.306 seconds. Okay, now that wasn't an unknown, but it's going to lead me to all kinds of good answers. If I know the time to the top, now I can find the distance to the top. I'll call that h up. Is going to be average speed to the top times the time up. Time to the top, okay? To the top. So I started at 3 and I ended at 0, so my average is 1.5. See, this becomes very easy. And the time to the top was 0.306. So I've got the height above the board as being point.
Please move the paper on.
Oh, sorry. Yeah, sorry. I got the height above the board as being, let's see, 0.459. Okay, that's the height up above the board, and that's what they want to know, above board. Okay, I'm halfway home. Halfway home. Now, what is the height? Let's see. What else do they want to know? Oh, the time in the air and the final velocity. Okay, let's do final velocity. V final squared equals V initial squared plus 2AD. Now, what's really cool about here is I don't need to know the time, and I don't need to know how high up it went. This formula is good because it just says, how far down is it at the end from where it started? Where is it at the end from where it started? So V final is going to be the square root of the starting speed, which was 3, plus 2, negative 9.8. Now, it ends up where? 1.8 down. 1.80 down. Now, be careful here. Do you see it? Gravity is negative, And where it ends up is below where I am. So that's a -2. Negative also. So if I do that, I come up with a number of 6.65. But I have to make it, if they want the velocity, I have to put a minus, meaning down. The square root doesn't tell you if it's plus or minus. So if it's heading down, I have to put a minus there to get it right. Okay? 665. Thank you. And then the total time in the air is also easy to do now. A equals V minus V naught over T. Time in the air. We started out, we ended up with minus 6.65 minus the starting speed, which was 3, over the acceleration of minus 9.80.
Can you move your paper down again?
Yeah, I will. Sorry, I get so wrapped up doing these things. Okay, so final speed minus initial speed, minus 3, over gravity. So that time, total time from start to finish is 985 seconds. And that's what they wanted to know. That was probably the most involved question we've done all day. Okay?
Quick question, Mr. Leary.
Please do.
Yeah, so when you solve for final velocity, I thought you were solving for the final velocity of the distance plus that extra distance at the top. So it could be like 1.80 meters.
Oh, it doesn't matter. No,
Really?
the final velocity doesn't matter what goes on in between the starting and end position. It doesn't matter. So because we're launched up, it goes higher, you know. All we needed to know here, a good question though. We just needed to know where is it at the end and what was the speed it started with. Okay? Where is it at the end compared to where it started? So it doesn't matter in between what's going on. So I don't know. I hope that answered your question. Yeah, we don't care that it went up to a certain place and came back down. We didn't. That formula takes that into account. Any other questions on number 4?
I had a question too. My screen froze while you were doing the height.
Oh, sure.
So how did you find the
Over here? Okay.
Yeah.
Okay. Let me review. Thank you for asking.
Thank you.
First of all, I went and found out how much time is it going to take to stop going up. I know it launched at the top, it's 0. It started at 3 going up. So that takes 0.306 seconds to stop, to get to the top. If I launched it at 9.8 meters per second, it would take 1 second to stop. So this is logical. It's 0.3 of a second, okay? Now, I like using this formula instead of D equal 1 FAT squared plus V initial T. I'd just like to take average speed times time. That's how I like to get this quick question done. So it started at 3, went to 0, so the average is 1.5. That's the middle speed times the time from here to get to the top, and that's where it is at the top. Okay.
Okay, thank you.
Yeah, good. Anybody else have a question? Please ask. Or forever float in Never Never Land. Okay. Let's go on to number 5. Let's go on to number 5. We're going to get a new piece of paper. Now, I know that a lot of you had questions with 4, 5, and 8, especially because you were emailing me. How do I do this and how do I do that? Okay, so we're getting it now. So let me find my number 5. Number 5. Oh, here we go. 4. All kinds of notes sitting here. Here we go. Here's a number 5. Okay. Number 5 says we're going to toss something over the edge of a cliff, and it's got an initial speed of, let me bring this down so you can see it. There we go. Match that up. Of 8.14 meters per second. Okay? It's tossed up and it goes na 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 na, and then it comes down to the bottom. We know that it's been in the air for 2.20 seconds. Now, if they tell you the time, it becomes a simpler problem. Okay? When you have to calculate time, it's a harder problem. They told us this. So how high is this building that it was launched from is one question. And then for part B, they say, how long would it take if we throw it down instead of throw it up? But we have to do part A first. We need to know how high the building is. So H equals question mark. Gravity is not negative 9.80 meters per second squared. 3 digits of information. 3. Okay. So I want 3 in the answer. So how high is the building? H equals question mark. As soon as you've got that number, type it in over on the right. And then I'll kind of let other people catch up to you. How high is the building? Now, this is pretty straightforward, so you should get this pretty quickly. Yeah, 5.81. Yeah, all you speedsters out there. 5.81. Let's show them how to do that. The height of the building depends on 1/2 AT squared plus V initial T. Okay, that's our formula we want. The height of the building, we'll call it H, minus 4.9, that's half of gravity, times 2.2 squared, plus an up speed of 8.14, times the time of 2.2 seconds. And that gives me, this is where it would go if there was no gravity. This is how much gravity is going to tug it down from there. Okay? So we get a height of 5.81 meters. And that, we're halfway done with the problem. Halfway done. Any questions on part A? 5.81. Thank you. Let's go to part B. Yeah, go ahead.
How do you know that that distance isn't the distance that the object traveled and is just the distance of the building?
Oh, the formula, this formula says, where are you from where you started? Okay, it doesn't, like before, it doesn't matter how high it went. It matters, where are you at the end from where you started? How long does that take? Of course, the faster you throw it up, the longer it's going to be in the air, but that formula takes care of that.
Okay.
Hey, Ben's here. Woohoo! I got 100% attendance today. Good. Ben, where are you?
I just got home.
Good. Nice to see you. I want you to I have somebody volunteer to give you the notes from the first half of class. These are super important now. We're going over all the problems of homework C. Okay? Thank you for coming. Okay. Now, the second part of this problem is we're going to throw it down now. We're doing 5. Throw it down at 8.14 meters per second. Now it's going to get there a lot quicker. So it says, how long is that going to take? How long will it take if we throw this thing down? Okay. Now, we could do quadratic formula. D equals 1/2 AT squared plus V initial T. I could do that with the quadratic, or I can skip around it by doing 2 little steps. I'm going to show you, if you don't want to use the quadratic, go ahead and do it if you want. You can do your A, B, C in quadratic. How many of you have a quadratic formula in your calculator already? It's in there. Wave your hand to me. You already do? All you have to do is put in A, B, and C. Okay. My old TI-83 or whatever it was, I kept using, had a program called Quad Form, and it would ask for A, B, C, and I hit enter, and boom, I get it, which works out pretty well. Okay, here we go. So you can do that if you wish, or I can find the final speed. V final squared equals V initial squared plus 2AD. Now, this is the distance down. That's the starting speed, which is negative. So here we go. So V final is V initial squared. That's minus 814 squared. This is the square root now. Plus 2 times minus 9.8. And the distance down, we already calculated from part A, is minus 5.81. So this is going to be a plus number. This is a plus number. Square root of that. And we get a final speed. Of course, it's picking up from 8, and it gets up to 13. Now, they didn't want that, but I'm going to use it now. That's the speed it gets to. If I throw it down, it picks up another, what, about 5 meters per second, because I threw it down while it was going down, okay? Now, I can find out the time. Acceleration is V final minus V initial over time. Time equals minus 9.8 times the time. Oh, no, sorry. V final was minus 13.4 minus a minus. Be careful here. It's minus a minus. It started out down at 8.14. Please notice these double minuses here. Minus.
Paper down here?
Yeah, sorry. Yeah, thank you. Yeah, just speak up whenever you need it. Okay. So V final was negative 13.4 minus a minus 8.14. And then we're dividing by A, minus 9.8. So it's minus this plus this divided by minus this. And that time turns out to be pretty darn quick, 537 seconds. Okay. And that's what they wanted to see. They wanted that answer. Now, if you did quad form up here, you could do it directly. All right, but I broke it into 2 parts. What's the final speed and what was the time? So it depends on whether you're comfortable with quadratic equations or not. Okay, either way, some of you are hot in math and you just don't think anything about using it. All righty, so that was number 5. I want to do 6 and 8, do a little bit of graphing, and then we're done for today. Okay, all right. I hope you appreciate going over problems slowly and methodically. I don't know if it's slow, but methodically. Okay, here we go. Let's do number 6. This is from your homework. So if you're not quite done, finish your homework by 11 o'clock tonight and fix it. And then you don't even have to ask for an extension. Okay. So number 6 says, I've got a shot putter. And I guess this is called a shot. They throw this thing up in the air at a speed of 10 meters per second equals VO. And it goes up and comes back down towards the head of the shot putter. This is the shot putter. This is the extended hand that threw it up. Okay, this is the shot putter. Eyes. Okay, so that's the shot putter. Now it's launched from a height of 2.3 meters. That's with the arm pushing it straight up. That's where it's launched from. But it's going to come down to the level of the head, and the head is 1.7 meters. So it's going to end up actually coming down 0.6 meters from where it started. This is the delta change in height right there. Can I see it? So it's going to drop at 0.6. How long does that take? That's the question. So T equals question mark. Gravity is minus 9.8. And we'd like to know how much time does that person need to get out of the way? Is it a short time or a long time? Okay. As soon as you get some seconds over on the right, tell me and I'll give you a pat on the back, a virtual pat on the back if you get it right. We've got plenty of time. So just go ahead and get it started. Pretend like this is a quiz question on Thursday and you're just going to grind through it. Get a good answer. So Ben, I told them that on Thursday there's about 16 questions. You get 2 shots at each answer. If the first one's wrong, it'll give you an X and then it'll ask you, do it again. Okay, and then it's 1 question will appear at a time. They aren't all on there at once. So I think you can go back, but when you're all done, you hit submit, I think. This is on...
Is there a time limit?
Yeah, it's 80 minutes. So you're going to come to class first. I check attendance, say good luck, are you ready, and all that kind of stuff. And then I'll start at like 5 minutes before, right after class starts. I'll start at 5 after that. Give you 80 minutes. And when you're done, you hit submit and you're done for the day. So, okay, 2.1 seconds. Yes. Akia. Where's Akia at? Wave to me, Akia. Where are you at? Yeah, you're fast. Whew. All right. Good for you. All right. Who's still working on it? Give me a little wave. If you're still working on it, give me a wave. Okay, I'm gonna give you 30 more seconds before I tear into it. Keep going. I should see the top of your head unless you're working on it. Yeah, AP Physics students are pretty capable, let me tell you. I'm doing college recs for a bunch of my kids from last year right now. So that's taking up some of my spare time. Yeah, 2.1 seconds, that's right. 2.10. Actually, 2.1 would be better than 2.10 because the data is only 2 sig figs. Okay, I feel compelled to get started on this thing. Now, if you want to use Pythagoras, or if you want to use the quadratic, you're doing this. D equals 1/2 AT squared plus V initial T in the vertical direction. So you got to get that D out of there. So Z 0 equals minus 4.9 T squared plus 10 T, and we're ending up, this was a down distance of 0.6. So I bring it over here, so that would be a plus 0.6. So there's your A and your B and your C for the quadratic. Okay, if you're going to do it that way. Now I'm going to break it into 2 parts, which I find just so much easier to understand. V final squared equals V initial squared plus 2AD. I need to do that to find the final speed. So final speed, when it gets to the head level, is the square root of 10 squared plus 2 times minus 9.8 times a minus 0.6. That's how far down the head is from where it was launched. And that final speed turns out to be 10.57 meters per second. But it's down. I have to put that minus in there. I have to put the minus in there. Now I can just do this. Time, it just comes from this little ditty right here. Time equals final velocity was minus 10. Can you see that, I hope? Okay, sorry. Minus the starting velocity of 10 over acceleration of minus 9.8. And I get a time of 2.1 seconds. That's the final answer. 2 sig figs. 2 sig figs. Okay. All right. We only have one to go. Plus somebody else asked about question 1, but I can do this one first. All right. Any questions about this? This is number 6. Ask now or forever go on to number 8. All right. You ready? Okay. Number 8. New piece of paper. Okay, this one says, okay, this is number 8. Number 8. There we go. Okay, this one says that we are 1.3 meters above the ground, and we are oh, this is a tennis ball, I think. And we throw this thing up and it comes down and hits the ground. Okay. We throw this thing up with an initial velocity of 8.6 meters per second. That's throwing it pretty fast. You're throwing it up in the air. It gets to the top and comes back down again. Okay, and hits. So this is I don't know, a midget, a tennis player or something like that. It's pretty small. Okay, so it says, what is going to be the, how high does it get? Okay, what's the height above the ground? Equals question mark. So we want to know this distance, this h. And we'd like to know what is the speed at the end. What is this v? And I think that's all we need. And then there's a part B. We'll get to that later. Okay, go. How high does it get above the ground? And what speed does it hit the ground with? All right. We only have 2 formulas. We don't have any time here, so that should be a hint to you. There is no time. So there's about 3 little calculations we need to do. If you get the total height from the ground, type that in over on the right. Now, ignore that phone. It's mine. So we want to calculate, to me, the strategy is how long does it take to get to the top? And then we can calculate how high is it above where it was released. We've done that before today. And add that to the 1.3 that it already is, and then I know how high it gets. And then we can calculate the speed later, okay? All right. All right, let's go, because I know some of you are kind of itchy. You've been sitting in classes all day long, so thank you for bearing with me. Let's do this. How long does it take to get to the top? Okay, T-top. I always like doing that because it's easy, because at the top, it's going 0 up there. I just like doing it this way. How long does it take to get to the top? And then we can calculate that little distance. So A equals V minus V naught over T. The time to the top is going to be equal to the final speed minus the initial speed, 8.6, over gravity. And I get that it takes 0.878 seconds to get to the top. That's useful. It's not asked for, but it's useful. Okay. Now I can find out how far is this little bit over here. Let me call that, I'll call this D. How high up does it go from where it was launched? So D equals average speed times time. You can tell I love doing that formula. Now the average of 8.6 and 0 is 4.3. And we know how long it took to get to the top, 0.878 seconds. So that says that distance for D, not H, but D, is going to be equal to 3.78 meters. Now H equals 1.3 plus D, right? Because it started 1.3 high. So above the ground, we add 1.3 to this, plus 1.3, and that turns out to be 5.07 meters above the ground. That's H. And that's what they wanted to know. Okay? All right, there's one more part to this. Oh, how fast does it hit? Okay. So, all right. Part B says when it being whatever this is, a baseball or something, when it is at 2.6 meters above the ground, how fast is it going? Okay, when it's 2.6. Now here's where a really good drawing is going to help you. When it's 2.6 meters above the ground, how much higher is it than where it started? Let's draw that. It starts at 1.3, and they want to know when it's 2.6 meters, what's its speed? Now, let's do that on a little drawing. So how much higher at 2.6 is it than where it started? It's 1.3 meters up. That's a plus. So this is the height of plus 1.3 meters above where it started. That's the D we're going to be using. They want to know the speed there. Anybody not get the drawing? Please say something now. No, I need 3 digits of information, you guys. Aki and Paul. 3 digits. Yeah, there you go, 696. Okay, so V final squared, here we go, we're on our last shot here. V final squared equals V initial squared plus 2AD. This is what I want to know. What speed will it have if it started at, what is that up there, 8.6. Gravity is negative 9.8, and it's up there at 1.3. Everybody see those numbers? 8.6 squared is the starting speed. 2, gravity is always negative 9.80. I should have, 3 digits of information. 8 point, okay. Oh, well, their information was only 2 digits. Sorry. We can round that off to 2. Okay. And then the distance is up 1.3. I've got the final velocity as 6.96 meters per second. Now, when you do a square root, it means plus or minus. This one could be plus on the way up. It could be over here. This is up. Put a little note on your drawing. It's at a height of 2.6 on this side. It's on its way up, so that would be a plus. Plus means up. If it goes around the top and comes around to this side, that would be minus, means down. It's over on this part of the parabola, over here. So plus means going up, minus means coming down. I think you can see that, okay? And that ends that problem number 8. And I know somebody asked me about number 1. I can do that after I release people here in a few minutes. So last minute notes is that anything that you're behind of, please look at Skyward this week. Maybe today or tomorrow. If there's a mistake, tell me. If there's not a mistake, then that's the grade you have right now. I'll be putting in homework C's tomorrow, and then I'll be putting in the tests after Thursday's test. Anything that you're behind homework-wise, you can ask for an extension till Thursday's test. The lab, almost everybody's got it in now, and I'm being very lenient on that, so please do. And I think that's, if you have no more questions, I know we're out 10 minutes early, but you've had a long day, and I've had 3 classes in a row, so you can tell my brain's a little frazzled too. So I'm going to say goodbye to you. I'm going to put this back over here on me. Get rid of Elmo for a second so I can see your face. So I'll say goodbye. If you want to stick around, please do. You got 10 minutes. You can have me personally to ask questions to, and we'll talk through any questions that you have. So I'll see you on Thursday. Please report into here on Thursday before you go off and do your test. So let me do that. Okay? Stick around if you want. Okay, goodbye. Those of you that are adiosing, goodbye. You're wonderful. Okay.
I'm that old, but you get on. Gravitational. Root 2 GM over R. It's inescapable. Cause I can find velocity. Miss Mills, she taught me. Gonna get 5 on this exam. But that's a guarantee. Elastic collisions I've been observing. But your momentum don't need conserving. My love for friction is concerning when you talk physics to me. Talk physics to me.